Welcome to the C4P RCN webinar. Today we're going to have two presentations. First, we're going to have Jim Beach to talk about the Specify software for collections. And later we're going to have Aimee Stewart talk about the Lifemapper Computational Platform. And the way we'll do this is I will be here as moderator, and if you have questions, just type them into the text comment section, and we'll ask them at the end. We'll ask our speakers to go for about 20 minutes, and then we will ask the questions of our speakers. So I will give you a verbal 3-minute warning when we're nearing the end of the time. So Jim, take it away.
Thanks, Mark. Okay, is that viewable? Well, I'm Jim Beach. I'm from the University of Kansas, and I see some familiar names on the participant list. Thank you for the invitation today, Mark. I plan to give you a 20-minute blitz elevator speech. Maybe they're supposed to be shorter than that, of the Specified Software project. And I hope we can get into some nice discussion about some of the infrastructure issues. That's really of great interest to me, is how you support and sustain community IT infrastructure these days, given all the economic pressures and such, and grant competition. So real quickly, Specify is a database platform for biological collections. It has kind of two agendas. One is to help collections manage their specimen information, both plants and animals, neo and paleo, and at the same time as supporting the routine collection management tasks, we also try to also accomplish the objective of mobilizing that data to the internet. So both things work hand in hand. Collections curation and management is fairly facilitated by getting collections information into a database. Specify is a highly customizable application. It was written that way intentionally because of the diversity of workflows and conceptualizations that exist across the biological collections community. Even though a lot of the collecting protocols have been pretty well formalized for a couple hundred years, there's still a lot of variation between institutions and between collections within an institution, and even within a collection among curators, for how they conceptualize and want to work with their data. So we built a user interface that was built and driven off of an XML specification data file, so that the user interface could be highly configurable for all those different disciplines and localizations. This is a brief summary of our history. We've been doing this for 27 years. Specify started off as the Muse project, originally headquartered at Cornell and run by Julian Humphreys. And we've been maintaining it ever since Muse. Specify came out about 8 years ago. And we've been doing that on 2, 3, sometimes 4-year grants from various programs at the NSF. Written in Java, so it runs on all 3 common desktop platforms. That was a pretty clear requirement when we went from Muse to Specify. 6 actually did that. And our database backend is MySQL. We'll be moving to Postgres in the future. It's open source. It's all on the web. You can go get it yourself and change it, whatever you want to it. We update the repository every day. And the project varies a little bit in terms of staff. Usually there's a director, myself, 2 or 3 programmers. We have a full-time help desk manager and a couple of undergraduates to do software configuration and testing for us. We do a lot of software testing because we release 2 or 3 major releases a year, plus a lot of smaller bug fix releases, and it's part of the development process. Right now we're spending about $400,000 a year on the project. About $250,000 of that is direct costs for salaries. We're in over 500 collections now across 30 or more countries. Our growth rate's been pretty consistent at about 15 to 18% for the past several years. And among paleo collections, we've got about 35 across 30 institutions. This is just to scare you. This was our original data model. I think it's gotten bigger since. And basically, it's all of the things associated with collection objects in biology, places, people, things, events, taxonomy, and geology in the case of paleo stuff. And this is the complexity that we're trying to hide from the user in a two-dimensional screen interface. And that's been one of our biggest engineering challenges, is try to make that as usable as possible. And we're still continuing to try to make that as easy and as straightforward, because thinking like this in order to manage your data is pretty outrageous to require of someone. Specify comes with several tools, sort of a suite of tools. The platform itself, which runs on those desktop OSs. We've got an EasyDB version, which doesn't require MySQL for small collections. We've got a Specify Workbench app, which is sort of like an Excel spreadsheet, which is linked through a mapping program, the Schema Mapper, to allow flat file data from Excel or directly entered into the Workbench to be pushed into that relational schema you just saw. So everybody can customize their own mapping for that. We've got a collection wizard, which sets up the databases and puts some data in them for initial digitization, and then a couple other utilities you can see there. I'll talk about Specify Insight in a minute. This is what it looks like on the PC. Usually you'll see it. It's menu-driven, tabs along the bottom, and you can get to everything with just a couple of mouse clicks. This is what a data form looks like for Paleo. In fact, different data tables are on the left side there, and the functions are across the top. So most of the time, users probably look at their data in this form view, and everything you see here can be highly customized for each collection. The labels can be changed of the fields. The fields can be repurposed. Fields can be represented as little subforms or as grids or as pick lists. If you click on those little eyes, you go through related tables to see the information about that object. The contents of fields can be formatted. The arrangement of the fields on the forms can be changed. Just about everything you see there. It's kind of a chameleon interface, and that's been a really useful capability because almost every collection that we work with requires either custom data fields or the existing data fields to be, customized or tweaked in some way. So that's kind of Battleship Gray version of that. Specify Workbench is a very popular interface, especially for people that are doing a lot of production data entry. It gets you away from that forms interface, which is good for querying and for one record at a time processing. But the Specify Workbench is, as I mentioned, it's kind of a production tool for either uploading from Excel right into this grid view, or you can type data in as you see them here. And then once you've populated a Workbench data set, which can be saved individually, so if you have multiple students, they can all be working on their own, you can push the update button or the upload button, and it will validate the contents. It will tell you if there are unique values here that are not in your database. It's good for catching misspellings. It does a couple of other integrity checks on the taxonomy and geography before it lets you upload the data. In the lower left, you can see the number of database tables that will be affected by this upload and the number of new records added to your database. So on the left there, you can see under the left side pane data sets. This one is the Seychelles data set. It can be saved before uploading, and you can have an editor look at it and basically treat your importing and uploading in a batch process. For other kinds of data, in fact, these 5 kinds here on the left, chronostratigraphy, geography, lithostratigraphy, storage location, and taxon, we offer a tree view. This is also something that is custom for each collection. People usually create their own trees with determinations from their existing specimens and the columns are customizable. And even paleo collections, you know, sort of have different variations of the chrono tree and the litho stratigraphy tree. This is another way to get to your data. You can click on these time periods or litho strata and get to your collection objects and see which ones are, you know, classified under those terms. So it's kind of a tree-based index to those two dimensions. And also geography, the same thing. Geography tree allows you to see which geographic units you have in your collection, and most people also use taxonomically, which goes for determinations with any tree that you care to create or put in there. We are currently having an interesting discussion about our paleo data model. This was one that we set up well, almost 6 years ago now for paleo context. So you can see we've taken the collection object, which is kind of the center of our processing environment, and all collections that you specify have the relationships on the top where collection objects are related to collecting events in a one-to-many, many-to-one direction from collection object to collecting event, and the same with collecting event to locality. Paleo context we have attached, as you can see, to collection object because, well, for various reasons, many collections have paleo information associated with the collection object itself and may not have any locality data. Those are neo-localities. Or there's other reasons why you'd want to be able to give a paleo context description to each individual object. Other collections are arguing currently that paleo context really is a qualifier of the locality. After all, you know, it's which stratum and time period you find the specimens in and the collecting event, and they're arguing for us to realign that attachment from collection object to locality. We're also looking at a third possibility of attaching it to collecting event, which kind of gives everybody what they want. That's kind of a compromise, but we haven't decided which way to go on that. But it's an interesting discussion we're having with an iBio group, several people who are on this session. Real quickly, we want to just mention we're moving to the web after having specified 6 on the desktops for the past several years. We're well into a web app development. This is just a browser window, and we have a test database on that. We're going to announce this data release in a couple days. And it's basically initially pretty much the same look and feel as the thick client. Here's the same Specify 7 web app in a web browser. It's the same deal with the forms and the fields. All of that stuff you see there is customizable, rearrangeable. Labels can be changed for the fields. And there's lots of fields that you can pick from depending on which things are important to you in your collection. Clicking on the little pencil allows you to edit those values, or the magnifying glass allows you to search for each of those individual fields. So this is a really exciting development for us. It's been working on it for about 2 years. In addition to data, we have attachments. This is one of the nice things about being on the web. We can also just put image attachments on. The CO there in the lower left of those images indicates that it's a collection object attachment, and there's several other tables, you can specify maybe 10 that you can attach attachments to. This can be image files or PDFs or any binary files that you like can be attached to several different data types, including taxon, collection object, collecting event, locality, the usual things. This is a new app that we're also developing. We've got some prototypes and some, well, this is a rough prototype that we have going. We're calling it Specify Insight. And what this is an iPad app that takes kind of a distillation of a Specify collection and puts it on an iPad. We don't copy all of your collection data to this for lack of space, and it's not really meant to be a collections management tool. It's meant to be a portable app that you can carry around with you and show your friends and family and your deans and your provosts and your directors what it is that they have in their collection. It's a way to bring collection data to additional audiences. It's not, although I think collections managers and curators will probably use it, it's a real fun app to be able to do gesture-based queries and browsing of your data with images and maps. But it's really useful for bringing collections data to new spaces, carrying it around with you, to meetings or, as I said, to your administrators' offices to let them, show off what you have. And we've gotten some really positive reactions on this in those kinds of situations so far. So we're pretty excited about releasing Specify Insight probably about a month from now. Work on iPad 2s and newer. Okay, so I've got about 5 minutes left. I think I put a couple slides in here because I noticed in your session plan that you'd like to discuss infrastructure issues or issues related to the maintenance of long-term IT infrastructure in the collections community. So these are some of the lessons we've learned. I hope these are not too glib, but they're important. First thing is IT support isn't just about software or how academically or intellectually pure your data model is. It's really about helping people. I mean, there's a real sort of retail service model here where if you don't connect to the people and in the collections and their needs and their requirements, it doesn't really matter how good your software is. It has to address problems that they have on a day-to-day, in the trenches level basis. We've always sort of approached collections from the bottom up. We started off by talking to people who are doing the work, collections managers and curators primarily. And it's been a slow development, but after 24 years now, it is caught on. Other ways of doing that would be to walk into the museum director's office and say, we have a software solution for you, and it will, take the monkey off your back and make your curators stop complaining. And the larger commercial organizations do that. It's a different style of marketing, and I guess you could look at that as sales, even though we don't sell anything. So we try to take a trench level support perspective and try to meet needs and be responsive to people with real problems. The second thing is the title of a book, Don't Make Me Think, is a book about software engineering. And it's true that even scientists don't like to change software, and they don't like interfaces that are hard to understand. Everybody loves spreadsheets. Even some of us don't mind working in databases. Ontologies are even more complicated. And as you get more sophisticated in your conceptual modeling of the information in the collection space, it gets more difficult to engineer user interfaces that are intuitive and which solve problems. And to the extent that people have to read the manual to figure out what some token or object is on your screen is kind of a loss. So we struggle with this all the time to try to make our approaches as intuitive as possible. People don't like to change software. None of us does. I don't like to change software. I don't even like to change Word if I don't have to. So migrating and transitioning people from, say, for example, a Specify 6 thick client on the desktop to our Specify 7 web app, will have its challenges, and that's partly why we kept it as similar as we could to the Specify 6, so that at least initially it wasn't a saltational change that people would have to relearn and get used to. I mentioned before our customizable forms and interface. That's really, really important. A lot of database projects die because one or a few people had an idea of what an interface should look like and how it should work. And even given the consistency and the 200 years of collecting protocols that are pretty well formalized, we still have lots of variation within and among collections for how people like to view and manage their data. Red Queen, as you know, software platforms are always evolving, operating systems are evolving, hardware is evolving, platforms are evolving, user requirements are evolving. It just goes on and on, it never stops. So a large part of being current and relevant and useful is just keeping up with all of those environmental changes that are going on with IT software. So it's a constant treadmill. You never can stop and just say that's good enough. It's always an evolution. I'd say over the long run, it takes leadership too. I mean, it takes a stable center or office or lab or group of people with perseverance and lots of patience and lots of ability to interact with people to grow a software or IT project. I don't see how to do that any other way. Top down works if somebody's paying you. The director's going to give you $100,000 to just deploy your software for the staff. But I think most of us are more interested in open source approaches, and that takes time. Attitudes and values change. Institutions, things we're doing today, curators wouldn't let us do 10 years ago. And likewise, 10 years before that, there were huge constraints to sharing data. People didn't want to put their data on the internet, back in the 90s and the turn of the century. Now it's a no-brainer. So attitudes change, software has to change with it. And you can never have enough software engineers. They're always the rate-limiting step in progress for a software cyber infrastructure project. So real quickly, these I think are the main issues going forward. Sustainability. We're under pressure from NSF to look at other options for revenue streams, charging fees for services, maybe a not-for-profit organization, or maybe even spinning up a for-profit parallel activity, which would subsidize the open source free versions of the software. There's a couple different business models there. We're thinking about all of them, but not anything really fits quite yet, but we'll have to do something in the next couple of years probably. Always need to integrate with broader communities, broader computing architectures, the earth sciences, computer science, library science, all the usual suspect communities that we're close to. I mentioned ongoing innovation and maintenance. Not only do you have to keep maintaining your software as the environment evolves out from underneath you, but you also have to continue to innovate and sell that innovation in order to attract funding. And then finally, really kind of a higher order goal and challenge is to evolve our users and our collections community so that they can have higher impact with their data and make it more relevant for broader scientific research purposes. We just can't do this for ourselves, for an internal collections community usages. We have to get the data out, and we have to make it easier and easier for people to integrate with broader computing and science projects. Mark, I think that's it. I'm over time a little bit.
I saw you come to a close. So if anyone has any questions, please type in the WebEx chat window. And Leslie, do we have any questions for Jim?
Hi, thank you. The first question is, what's the cost benefit of making everything customizable? You mentioned some of the benefits to the users, but has there ever been an attempt to combine specified collections and the customizations provide issues?
Well, I think the software that allows the interface to be customizable was very carefully designed and planned and developed, and probably the cost of that was, an extra several months, maybe an extra year of development. So, so if you figure you that might be somewhere between $50,000 and $100,000 to get that kind of flexibility in an application like that. And the nice part is that it opens us up for new fields. I mean, we could pretty much change that interface for almost anything if we had financial support to support other collection types. For example, archaeology often comes up for us. Living collections like aquaria and zoo often comes up. So there's still more upside. We haven't taken full advantage of the flexibility that we have.
Thank you.
I should say.
Go ahead.
I should say one more thing. The interface is derived from what we call a schema file, which also defines our data table. So by adding new data tables, we can automatically create the forms for those things. It's all automatic.
All right, great. Thanks a lot. The second question is, how did you develop your user requirements, and how do you engage with users now in order to develop new functionality?
That's a good question, and we've evolved those techniques over the years, and I'm not sure we have the best one yet, but by far and away the best source of ideas and potential targets for innovation come from the users themselves. That's an interesting dichotomy, though, because we have to pay attention to what's happening outside of the collections community. And as you know, there's lots of buzz around cloud computing, and it's largely why we're moving to the web ourselves. So sometimes the industry or the science just sort of pulls you in a certain direction. But as far as individual capabilities and functionalities, we get suggestions every day, and we maintain a long list and bug new feature requests in a database to try to prioritize those.
Okay, thanks. Next question is, you showed a slide of a suite of many applications. I'm interested in which are the most popular and the least popular, and if you know the reasons why.
Well, probably the most popular is the specified platform itself, because that's the main application that everyone uses. I'd say the least popular are probably the small utilities that are not used very often. Sometimes they're only used once, like the specified DB wizard, which creates the initial database structure. The backup and restore utility. We didn't talk much about the schema mapper, but that's a really powerful tool for mapping the data concepts in specify to an external database schema. So if you have a flat file format that you need, or even a structured relational format, the schema mapper is an extraordinary tool for exporting data in various formats and styles.
Okay, here's a big question. Over the 27 years, does anything come to mind that's the biggest challenge for keeping the technology up to date?
Well, I guess that would have to be staffing. We have been really lucky here in mid-America in attracting terrific programmers, and to be honest, it's usually people who are anchored here in Lawrence or in the Kansas City area, and who don't want to double their salaries by moving to the East or the West Coast. And extraordinary commitment and high value for what NSF pays. But we never have enough developers. We could double our productivity if we had twice as many developers. So we're always striving to find funds to hire more.
Okay, another question is, with the move to the web platform, do you plan to collect new types of user statistics?
That's a good question. We haven't implemented that in the web platform yet, but I think eventually we'll probably do something along those lines. We've always wanted to provide those stats back to the source collection so that they could use them in their reporting. That's part of database management, and right now people have to go to weblogs and things to get an idea of how useful their collection is. We're working on a new project that is likely to be funded soon to develop more software tools for monitoring the use of individual specimen records so that source collections will be able to obtain information on how individual records have been used by other sites around the country and what they've been used for.
Okay, I think that's about all the time we have. I want to thank you, Jim, for telling us about Specify, and we're going to move on to our next speaker, who is Aimee Stewart from the University of Kansas as well, and she's going to talk about the Lifemapper Computational Platform. So again, type your questions into the chat platform, and then Leslie will read them at the end. Aimee?
Thank you, Mark. Hi, I'm Aimee Stewart. I'm lead developer on the Lifemapper project, and you'll see Jim Beach's name here again. He is,
Aimee, are you sharing your screen? Just checking.
Oh, no. Okay, just a second. I am not seeing. Okay, here we go.
Great.
Okay. Get back here. Okay. Now you'll see Jim Beach's name again, and so he is our fearless leader on this project as well. So Lifemapper, I just want to give you a little bit of background on that. It's a software project at the University of Kansas Biodiversity Institute, and it has two core functions: providing data and research tool through web services. And those data consist of climate data plus globally distributed species occurrence data. And we get that from the Global Biodiversity Information Facility, which aggregates it from many different data providers across the globe. From all these data, Lifemapper calculates potential species distribution maps. Then we make all of these input and output data available to be downloaded using open geospatial web services or viewed on our website, and they're also easily downloaded or accessed programmatically. The second set of tools are research tools, including two modules. The first module is species distribution modeling. We call it LMSDM. That's for mapping the potential distribution of individual species. And then the second module is LMRAD, or range and diversity. And that's for looking at landscape level ecology with multiple species. All of the tools in these modules are available through web services, and we provide easier access through a Python client for programmatic access. And then also we've written a plugin to the open source GIS application QGIS. Then another relevant piece of information here is how Lifemapper is designed. We've recently refactored it to sort of separate the different components. It's a multi-component system with each one designed to communicate with the others but work independently. And then the goal is to have multiple instances of one or more components running for individual projects, groups, or anyone else who has a need or finds it convenient to maintain a local piece of the Lifemapper infrastructure. This also allows Lifemapper to scale for greater computational and data storage needs. And it allows those with data access restrictions to control where their data is deployed. It also provides a backup or a fail-safe in case any particular component needs maintenance or fails. We can easily spin up another version of that same component to take the place of the one that's down. So the components include a data and management component. That's the LMDB server on the left-hand side of the screen. It stores all archive input and outputs, as well as user input and outputs. It also creates jobs for analysis requests by users or by the archive, and it tracks the status and the parameters of all experiments. And I think you need to back up here. The archive consists of that all of the occurrence data from GBIF, and then we are constantly updating that archive to create distribution maps from that GBIF data and the climate data. So then the compute component takes the jobs from the management. The LM compute, you can see multiple instances of it over sort of almost to the left side. And it gets jobs from management and returns them when they're complete. The web server, the web component, sits between the LMDB server and LM compute. It communicates between the compute resources and the DB server, the management component. It also communicates between users and the management component to request jobs or to request data or whatever. Then we also have external clients. As I mentioned, we've got a Python client for programmatic access. We've got a plugin to QGIS, which allows people to submit jobs or retrieve outputs directly into a full-featured GIS application. And since this is all geospatial data, it's the perfect application for then doing further analysis on that data, those data. So LMSDM is the first module that we built, and it's kind of the basis of Lifemapper to begin with. So first what we do is we input species occurrence data. And for the archive, that means the GBIF data. And what that is basically map coordinates of where a species has been found. We put that together with environmental data for those coordinates. In our case, we're using temperature, precipitation, and elevation data to create a model of the habitat best suited for a species based on those known locations. Our back-end computations use OpenModeler and Maxent softwares on our clusters to create these models. And then the models are projected back onto maps of the environmental data to find other areas where the habitat is suitable for that particular species. All of the modeling and map projecting takes place on one of the 4 clusters that we're currently using for the computations. And those are at San Diego, at University of Florida, and then we have one here at the Biodiversity Institute, and another at our Advanced Computing Facility here at KU. The second set of tools that we're developing are the range and diversity tools. And in this particular workflow, we begin with geospatial data representing species habitat ranges. And those can come from anywhere. They can come from predicted species distribution maps. They can come from range maps or expert maps. And then we put those in for multiple species. It could be hundreds or thousands or even tens of thousands. These data are then summarized in a presence-absence matrix, or a PAM for short, which then contains much of the information needed to understand species diversity in a particular area. From the PAM, we have different ways of representing species diversity, such as scatter plots, indices, and other quantifications. We connect these all in an implementation using web services and client software. These tools allow us to combine these range maps for community-wide landscape level biodiversity measures. Here's just one of the outputs of the calculations that you can create from a PAM. You can create a range diversity plot where the distribution in the plot is determined by the similarity of sites. And in this particular case, you can see where different areas in Africa are showing up as similar areas in the range diversity plot. So you're plotting mean proportional range size here on the x-axis against the proportional species diversity on the y-axis to show different spatial patterns. And here is that same or a different plot in the QGIS application, and that is tied to the map behind it. And that map is showing, I believe that's showing species richness of Africa. And you can link these data spaces in QGIS, these two windows. And lines of isocovariance in the left side along the y-axis of the plot are shown geographically on the east side of Madagascar on that map. Then you can brush the data in the plot to highlight areas in the map. And one of the things that we're working on right now is linking trees, in particular phylogenies, to maps and plots. So this here is showing the site-based plot, and it's based on species-derived statistics. And the data in the plot can be brushed and dynamically illustrated in the tree viewer, the phylogeny viewer, to show the relatedness of species and communities and allow us to explore community assembly. So one of the things that we're working towards in both data services and analysis services. And this is something that was envisioned by Gary Geller, a scientist with NASA, and he calls it the model web. And this is a system of interoperable computer models and databases, as he says, communicating primarily via web services. And so we're involved in a collaboration with the University of Texas at El Paso and the University of New Mexico to take a stab at this model web. And so this project is called ELSWeb, or Earth, Life, and Semantic Web. And so in this particular project, we're using marked up data from EDAC and services from Lifemapper. We're using the provenance standard. I'm not sure, I think it's an accepted standard, an accepted W3C standard now. And we are semantically reasoning over the metadata for both the services and the data to determine what types of data are appropriate and can be input from EDAC into the Lifemapper services. So the semantic mediation layer is called SADI, and that stands for Semantic Analysis and Discovery Infrastructure, I believe. So the semantic reasoning uses the PROV W3C standard, and it's designed to answer the questions: what kinds of data can we use? Where can I get the data? How was the data generated? Who was responsible for publishing it? And when was it generated? So there are different limitations to this model, and we're trying to answer those through the SADI services, and trying to come up with some overlapping ontologies between EDAC and SADI and Lifemapper that allow us to do this reasoning over these services. So some of the infrastructure needs that that we've had trouble with and that we're working on right now, we're extending our operations, and we're thinking of additional analysis tools and extended workflows that will demand additional computational resources. And since we've been we've decoupled our compute services from the rest of the infrastructure, and now we have that deployed in several different places. So that's something we're working on right now. Another issue is that we're expanding our archive to do more of these multi-species analyses, and so storage is becoming an issue, and not only just the size of the storage itself, but allowing efficient query and retrieval over that storage. To participate and to extend this model web, which I see as a really valuable tool that would improve the lives of biodiversity scientists and give them so many more options for analyses. We really need to make sure that all of the available data out there is marked up with some standard types of metadata. And there are several different standards out there, and they're getting a lot of use. We need more standards for controlled vocabularies, and actually maybe not more standards, we just need some more data out there, more controlled vocabularies and ontologies for reasoning over these metadata. SADI is a great reasoning tool over that, and it's fairly mature at UTEP, and they're doing a lot of things other than the ELSWeb project with that. As we continue working on this, we've been working on a lot of biodiversity computations and analysis, but we're also working on more computer science type extensions, making the whole system more modular, and being able to deploy not only the computational resources, but the whole management component and also the web server component, so that we can deploy pieces or the entire system for individual institutions, collections, or aggregators. And that would allow them to do a whole bunch of computations and create special purpose workflows for their particular data, and allow them to plug in other interactions with other services. And we're making this as configurable as possible. So like I said, we've accomplished this with the computational resources, and it's a little more complex with the management services. But that's something we're working towards right now. And I think I'm ready for questions.
Great, thanks, Aimee. Leslie, do you have any questions?
Okay, thank you, Aimee. The first question is about the controlled vocabulary. Do you have any particular examples of the issues where you need more control over the vocabularies? How do you plan to make progress on this front, and can the C4P community help?
Well, primarily the use of those controlled vocabularies, I see as using those when you're trying to, I'm trying to think of the right word. Basically, what we want to do is be able to resolve the needs of one service with the data of another service. And so, for example, we have a lot of climate data that we use for the SDM modeling. So we're using normalized climate variables. So having some sort of controlled vocabulary that would describe, say, the term of aggregation. So the variables that, or the data layers that we're using are 30-year aggregated variables, and then we normalize them over months and over quarters. So we'll normalize them over the coolest quarter or the wettest quarter. And there's just so many different things that are in those computations, and we need a standard way of describing those so that you can determine if you can put your layers with our layers. We're using 30-year aggregations, but you can aggregate for a single year. You can aggregate for, you know, if you want to aggregate into the past, it might be, you know, 10,000 years, something like that. Then there are also, you know, just the simple thing like units. Like, so if something is in millimeters, we need some kind of ways of converting those millimeters to inches. And I know this seems like a simple problem, but I don't think it's something, it's been attacked before, and it hasn't really been solved. So those are some of the things. And this is not really my area, so I don't feel like I'm describing it very well, but it's something that we are working on with University of Texas. And the semantic mediation in particular is the thing that they are expert at.
Great, thanks for the answer. The next question is a point of clarification. Who chooses the simulations that are run? Are those chosen by the users themselves or by Lifemapper? And there's a second part of the question depending on the answer.
Okay. I don't think I was very clear in the way that in the way that our data is set up. We have a whole set of archive data, and that is based on the GBIF data, and it's based on the environmental climate data that we've got. And so in that workflow, we just constantly are updating the species data from GBIF, and as the point data is updated, then we rerun all the models. So those are all chosen by us, and basically we just try and run through everything. But those tools are also available as services to users. And in that case, the user picks all of the parameters, they pick the algorithm, they can upload their own data, they can upload their own point data, and they can upload their own climate or environmental data. It doesn't have to be climate data. It could be satellite data. It could be whatever they want. So the answer is both.
Okay, and the second part was, for the part where the users choose the data, do you find that there are certain species or a certain time period or location that is more popular than others, and would that guide the simulations that you run?
You know, we have not ever done any sort of analysis of the data that users are using. So I don't have a good answer for that. Basically, in our archive, we're just trying to run everything, and we're not focusing on any one area or any one species or group or anything like that. One of the things that we would like to do, though, is, as I was saying, be able to deploy, you know, parts or the entire Lifemapper application for other institutions or other locations, so that they can have a whole archive that is specific to their type of data or their area or whatever they want.
Okay, thank you. The next question is, I saw that there are some planned links between Lifemapper and Specify. Can you talk about those a little bit more?
Well, I'm not sure Jim is still online.
We can unmute him.
Hello?
Yep, we can hear you, Jim.
Great. Yeah, that's funny. That's a good question. And we've all wanted to do more with that. I think that the sort of the challenge there is to try to find the right application or the right capability to merge those two projects. The obvious thing would probably be to specify users to see species distribution models for the species that are in their collection. And since Lifemapper is all web services based, that would be a fairly easy thing for us to do. Just a few lines of specified code, and we could call those models and maps from Lifemapper. But we're not sure how many collections people actually are interested in niche models. It's a biogeographic research area, so we're not quite sure. The more interesting, maybe, application of niche models for collections management would be to use them as validation, for validation purposes, to see if the georeferences and locations of points in a person's collection fall within the predicted space, geographical space of that species, and then if they don't, to flag them for review as kind of a data quality improvement tool. So that's kind of what we're thinking about right now for integration between those two in the future.
All right, thank you for your answer. There are no further questions in the chat right now.
Let me just take the time to thank our two speakers for this week. Thanks very much for sharing your knowledge and your resources with us. And I want to remind our audience that we have one more webinar scheduled in 2 weeks in the Paleobiology series, and that is on May 27th. And for those of you who are going to participate in our workshop, just a quick reminder, it's next week. And we sent out an email a while back with some homework asking you guys to fill out a survey and do some reading. And so I really strongly encourage you to do that so we can hit the ground running when we begin our workshop here in Washington, D.C. So thanks very much, and we'll see some of you next week. Take care.